Welcome to the Explainer. We're jumping right in today because we've got a massive topic to untangle: the shrinking carbon budget and what this energy transition actually looks like on the ground. Look, we all hear a ton of noise about climate goals and renewables, right? But today, we're cutting through all that. We're going to look straight at the data, the models, and the deeply complex geopolitical web that makes this whole thing so tricky. So, let's get into it.
Okay, let's dive right into this with a really helpful analogy from energy innovation. You can basically think of our entire CO2 system as a giant bathtub. The open tap, those are our emissions. And the drain, those are the Earth's natural carbon absorbers, like oceans and forests. When you start talking about atmospheric carbon, things get highly technical super fast. But this tub concept, it grounds everything perfectly. The issue we're facing isn't just that the tap is on, it's the insane pressure at which the water is blasting into the tub. To really bring this to life, we're going to bring in a recurring friend for this explainer. We'll call him Razum Stickman, or Razum Stickman. Now, if you picture Razum frantically trying to wrench that bathtub faucet shut while water just pours over the sides, yeah, that perfectly visualizes our current dilemma. The data is clear. Our emissions tap is running at roughly double the speed of the Earth's natural drain. So think about what that means. Even if we completely stop the growth in our emissions, just keeping the tap running at its current pressure, the tub is still going to overflow. To actually stop the overflow, we have to radically tighten that tap until the flow matches what the drain can realistically handle. So let's look at the actual numbers behind this bathtub problem. You see that 450 parts per million guardrail that Razine Stickman is pointing at so nervously? A lot of scientists agree that this is the absolute upper limit we can hit before things get catastrophic. Now, for some context, before the Industrial Revolution, we were sitting pretty comfortably way down at 280 parts per million. But if you track that business-as-usual trajectory, it's literally rocketing right past the safety guardrail. The visual evidence is honestly undeniable here. Business as usual equals a guaranteed overflow.
And this brilliantly illustrates the cost of delay. If you look at the shapes of these curves, they represent the different pathways we can take to stay under that 450 ppm limit. The area under the curve, that's our total carbon budget. And the logic here is simple, but it is brutal. The later global emissions peak, the more drastic the drop has to be later on to stay within budget. Just look at our friend tumbling down that absolutely steepest curve. If we delay peaking, we don't get a nice gentle slope, we get a cliff. And a drop that steep, that represents severe economic and social trauma. It literally means we'd have to shut down high-emitting industries virtually overnight just to hit the required reductions. So delaying action doesn't actually save money, it just guarantees trauma down the line. Moving from the theoretical to the specific, let's compare two totally different futures modeled by the UNFCCC. First up is the baseline scenario. This is the grim reality of a world where absolutely no climate policy is set, basically that unchecked trajectory we just talked about. Contrast that with the 1.5C EPIC scenario. This stands for a strict 1.5 degrees Celsius target achieved using an equity per capita criterion to share the global mitigation effort. Seeing these side by side really hammers home the incredible gap between our default path and the highly disciplined, globally coordinated pathway we actually need to stabilize the climate. So how do we actually bridge that massive gap? Well, we have to shift our focus to the physical solution. We are currently right in the middle of swapping out the black lump of coal for the shining solar panel. We're talking about the absolute phase out of fossil fuels and the mass transition to renewable energy. It is a monumental physical task. We're replacing the very engine of the Industrial Revolution with entirely new infrastructure. But as you'll see, this isn't just about avoiding disaster. There are massive, tangible benefits to making this swap. In fact, according to a recent UN carbon brief, shifting to renewable energy is, quite simply, smart economics. It's really no longer just an environmental imperative. It's a financial one. Yes, the upfront infrastructure costs are high, no doubt about it. But the fundamental financial logic heavily favors renewables over the long term. This isn't just about saving the planet anymore. It is about building a more resilient, cost-effective, and economically sustainable energy grid. The UN's perspective clearly frames moving away from volatile, finite fossil fuels as a strictly rational economic necessity for our future. Now, what's really fascinating about this slide is how the benefits extend way beyond just economics and climate. When you dig into the Paris Agreement modeling data, you see that mitigating carbon also drastically reduces other pollutants, specifically PM 2.5, those dangerous fine particulate matters that cause severe respiratory issues. These models show profound health co-benefits.
We're talking about quantifiable reductions in PM 2.5 concentrations and, most importantly, massive numbers of regional premature deaths avoided. So transitioning our energy grid literally saves millions of lives just through cleaner air.
But obviously, taking these clean, clear models and actually applying them to the real world, it's incredibly messy. It's like trying to solve a puzzle on a globe where all the pieces keep shifting. This transition does not happen in a vacuum. It is deeply entangled with global crises, incredibly complex supply chains, and shifting geopolitical realities. Moving from fossil fuels to renewables means completely rewiring global trade. It creates new dependencies and forces us to navigate a landscape where energy security and national interests are constantly colliding.
And we've seen exactly how these geopolitical shocks can act as catalysts recently. Take the European energy crisis, for example. According to a report from El Watan News, the sudden disruption in traditional energy supplies taught Europe a pretty harsh lesson. It shifted the whole narrative of phasing out fossil fuels from being this long-term environmental goal to being a short-term absolute necessity for survival and sovereignty. The extreme volatility of fossil fuel markets is objectively forcing nations to accelerate their transition to renewables just to secure their own energy independence.
However, that massive rush to build renewable infrastructure brings its own deep geopolitical conflicts. We're seeing completely opposing narratives regarding the solar supply chain right now. On one hand, according to reports from media outlets like the BBC and CNN, there is new research alleging the use of forced labor from Uyghur Muslims in the production of solar panels in China's Xinjiang region. But on the other hand, according to China's state-run newspaper The Global Times, these allegations are strictly rejected as lies. The Global Times cites highly automated facilities, describing humming production lines operated primarily by robots, which is obviously in stark contrast to the accusations. This just highlights the incredibly fraught political landscape surrounding the exact materials required to build our renewable future.
So, the crucial point is, despite all of these massive geopolitical hurdles and supply chain complexities, real, systemic progress is actively happening. Just look at this number. 47%. According to Eurostat data, a staggering 47% of the European Union's electricity was generated entirely from renewable sources in 2025. We are not talking about a niche alternative anymore. Renewables are rapidly becoming the absolute backbone of the grid in major global economies. And the ambition just keeps scaling up, with the European Commission continually analyzing higher targets to push that percentage even further.
Which brings us to the ultimate question we have to answer as we stand at this fork in the road. Are we willing to make the rapid, difficult changes today to avoid an impossibly steep economic and social drop tomorrow? We've seen the bathtub overflowing. We've seen the very real cost of delay. And we've seen that the transition is both economically smart and actively underway. The math of the carbon budget simply doesn't care about our politics or our hesitations. The road to the left is business as usual, which leads straight to a cliff. The road to the right is immediate transition. Which path will we choose? Thank you so much for joining me for this explainer. I hope this look at the data gives you a clear view of the road ahead and maybe sparks a few new questions of your own.